Alright guys, so here's a special video for all of you that get on Edmodo. This is going to be almost exactly, this is a test right here. I just changed a couple of things. Most of it's multiple choice. So number one, what you need to know for number one, you need to know the vertex form and standard form. So what's vertex form? It is y equals a parentheses x minus h squared plus k. Now what is standard form? Well, for standard form, let me write it over here in red. And there is your standard form equation. So question one is either going to be vertex form or standard form. Make sure you know both. Moving on to question number two. What is the equation of the axis of symmetry of this equation right here? Well, this equation is in vertex form. So you could see that the vertex is really -3, 12. And we know that the axis of symmetry is simply going to be that vertical line that goes right through the vertex. So it must be x equals the x value of your vertex. Once again, the axis of symmetry is x equals the x value of your vertex. One more time. There it is. Axis of symmetry is going to be the equation x equals the x value of your vertex. Okay, keep that in mind. Let's move on. Number 3 on your test tomorrow is going to be exactly this question. The graph of f of x equals 2x squared plus x opens blank and has a blank value. Okay, so what do I mean by that? Does it open up or does it open down? Well, the a value is positive, so that must mean that it opens up. Okay, if this were a -2, then it would open down. So knowing that it opens up, okay, let me just do a quick sketch of a parabola that opens up. This will be also have a minimum value, okay? So we're filling in that second blank with a minimum value. And of course this will be multiple choice, so just make sure that you know if the a value is negative, then it's going to open down, which means you would have a max value. If the a value is positive, then it opens up, which means you have a minimum value. Hopefully you guys will remember that on tomorrow's quiz. Let me clear this up right here. If we move on to this next one, it says a related graph of a quadratic equation is shown at the right. Okay, so there is no picture at the right. On the test tomorrow you will have one. So let me do this. Let me just do a quick sketch. Let's say this is at -2 and at 3. Okay, so let's say we have a parabola that crosses here, and let's say it's opening down, okay? So what could you tell me about that? Let's look at this question over here. It says, use the graph to determine the solutions of the equation. Remember, solutions are x-intercepts. So this x-intercept is -2, this x-intercept is +3. So the solutions are x equals -2 and x equals +3. It's that easy. Let's take a look at number 5 here. The quadratic function f of x squared minus 3 has blank, and let's choose from down here. Okay, so on tomorrow's test, you're not going to have this one, and this one. You're going to have one of them, all right? So let's just pretend that this is not here and this is not here right now. Let's just focus in on this one. F of x equals x squared minus 3. Okay, so does it have no zeros? The question is, no zeros. What you need to know is that zeros mean x-intercepts. That means answers. So does this cross the x-axis? If it doesn't, then it has no zeros. If it touches it at one point, then it has exactly 1 0. If it touches it at 2 points, if it crosses through the x-axis twice, then it has 2 zeros. More than 2 zeros, I don't know how it would cross more than twice. So let's think about this first one, f of x equals x squared minus 3. All right, well, if I do a quick sketch, and let's think about this. This is in vertex form. I just need to think that should have parentheses and a minus h in there. Now, since there is no minus h, you could go x minus h squared plus k. And the h value we know is 0. So it's x minus 0 squared minus 3 is the k value. So on this one, we know that the vertex is 0, -3. So 0, -3 is down here. I already know that the A value on this thing's positive, which means that it's opening up. And that's already good enough to say that it's going to cross at 2 places, at 2 intercepts. So if you know it has 2 x-intercepts, then you know it has 2 real zeros. So does it have no zeros? No. Does it have 1 0? Only if it were to touch at one point. Does it have exactly 2 zeros? Yes, it does. It has exactly 2 zeros. So I would put a C right there to represent that it has exactly 2 zeros. Let's look at this one over here. This guy right here. Okay, anyways, this guy is also in vertex form, and we could see that the vertex, HK, is going to be a +2 and a -3. Now, if we think about the xy plane, and you go to the coordinate 2, -3, 1, 2, 1, 2, 3, you're down here at this coordinate, and notice that this A value is negative. So what does that mean that the A value is negative? Does that mean that it's going to open up or open down? The A value being negative means that it's going to open down. So if I just do a quick sketch of that, I will see that it doesn't cross the x-axis. So what does that mean? It does not cross the x-axis. That means that it's not going to have any real x-intercepts, which means that it doesn't have any real answers, which means that it doesn't have any real zeros. So when we look for this one, does it have exactly 2 zeros? No, it doesn't even cross it at all. More than 2 zeros? No. Exactly 1 0? No, that's only if it would touch. It has no zeros. Okay, so that would be the answer to that next one. So you would put an A right there. It has no real zeros. It has no real answers. And of course, this third one down here, f of x equals x squared. That's the parent graph of all parabolas. That's really easy to do. That one, if you think about vertex form, it would be something like this. Let me write it in blue. It would be y equals, the A value is 1, parentheses, x minus 0 squared plus 0, because there is no h and k, which means that the vertex is at the origin 0, 0. And of course, this is opening up because the A value is positive. Again, that's the parent of all parabolas. And how many times does that cross the x-axis? Oh, it has 1 x-intercept. It only touches it at one point. So if it only has 1 x-intercept, then it has only 1 real zero. It has exactly only 1 0, so that's a B right there for that one. I hope that one made sense. There's only one of those on number 5 tomorrow on the test. Number 6, we need to solve this by factoring. Okay, so how am I going to do that? I want to go parentheses equals 0, x, what times what is -10, that if you add together is -9? Well, that would be a -10 times +1. Now, when you split it, you're going to get x minus 10 equals 0 and x plus 1 equals 0, which means that you're going to get two answers, x equals 10 and x equals -1. Yes, there's going to be some that easy, and it's going to be number 6 on tomorrow's test. Number 7 on tomorrow's quiz, test or quiz, I don't know, we'll see how well we do. Distribute, 7 times 1 is 7. 7 times 3 is 21, but with an I. 21 with an I. And then distribute 2i times 1, that's positive 2i. And then 2i times 3i, that's positive 6i squared. Now remember, I squared is really a -1. So what you really have is -1 times 6 right here. And we could combine these middle values, the 21i plus 2i, that's 23i. And again, this is a plus 6 times -1 with a plus 7 out here in the front. Let's combine the 7 with the -6. So that's really just going to be a +1 plus 23i. And that's your complex number answer for that question right there, which is number 7. Let's move on to number 8. It says solve by using, to solve, and these are all question for question exactly the way it's going to be on tomorrow's test. I'm just going to change a couple of values. Number 8. Solve x squared plus 8x plus 16 equals 25 by using the square root property. How would you first rewrite the equation as? Well, remember, if you want to use the square root property, you're going to have to complete the square right here. But technically, we don't even have to really complete the square because it's already a perfect square quadratic trinomial. In other words, parentheses squared equals 25. And what belongs in here? X, and then half of 8, that's plus 4. And that's only because this is already 16, and 4 times 4 is 16. That if you add together is 8. So this is the setup, and that would be option H right here. Moving on to the next one, number 9, it says find that perfect C value that makes this a perfect square, quadratic trinomial. Well, how do you find that C value? You're going to take half of 12 and then square it. Half of 12 is 6. 6 squared is 36. So that's your perfect C value right there. Number 10, the quadratic equation is to be solved by completing the square. What would be the first step? Well, if you were to take this one and make space for your C value and put that space over there, and you take half of 6 and square it, you'd be adding 9 to both sides. So you'd have x squared plus 6x plus 9 equals 1 plus 9. And let's check and see if any of those are the multiple choice answers. Let me see. Yeah, that's it. That's H. So H is the correct answer for that one right there. Okay. Number 11, find the exact solution by using the quadratic formula. I'm not going to waste any time on that. You guys could do A, B, and C and use the quadratic formula to find those answers. On numbers 12 and 13, I give you two quadratic equations, and I ask you to use the discriminant to determine the number and type of roots of each equation. So let's use a discriminant. The discriminant is the value inside the square root, okay? So I'm really asking you to look at b squared minus 4ac. And if you do b squared, that's negative 4 squared minus 4 times 1 times 9. So that's really going to be 16 minus 36. Now, what is my answer going to be, or my discriminant going to be? It's going to be negative. As long as I know that it's a negative number, you know that inside the root you're going to have a negative number. You know it's going to be imaginary answers. You can't have real answers. They're going to be imaginary. They're going to be complex roots. So for number 12, if you look at the multiple choice answers here, F, G, H, J, does it have two complex roots? Yeah, absolutely. This one has two complex roots, because if you have a negative inside the square root, it's going to be imaginary. Complex roots are imaginary answers. It's definitely not two real answers. That can't happen. It can't be that it has two real answers with irrational roots. That's just a square root. And you don't have one real answer. So they're complex roots because your inside term is imaginary. Your discriminant is negative. Number 13, in order for you to do this, you have to first rewrite it in standard form. So you first have to think x squared minus 6x plus 9 equals 0. And I'll tell you what, you could use a discriminant, right? Negative b squared minus 4ac to check if it's negative. That way it'll give you imaginary. But I know for a fact that I could factor, split, and solve. So x, and if I put a negative 3 and a negative 3, and it's equal to 0, my answer will be x equals 3. That's just one real answer. So that would be this one right here, one real answer. Okay. Number 14, what is the vertex? That one's easy to do. What's the vertex? It's positive 5 and positive 1. Remember, you always think opposite on H and take K for what it is. Jumping to number 15, what is the equation of the axis of symmetry? Well, if you know your vertex, which is negative 3 and 2, you know that your axis of symmetry has x equals, or is x equals the x value of your vertex. That's your axis of symmetry, so that's the answer for that one. Let's look at the next one right here on the test tomorrow. Find the vertex. Well, that one's easy. It's simply h and k. So once again, my vertex for this next one will be positive 3, and the k value is 0. There is no k value. Number 17, which quadratic function has its vertex 2, 3 and passes through 1, 0? So if it's 2, 3, that means that you're going to see it as negative 2. So it could be this one, could be that one, can't be h, so we're going to just cross that out. Okay, and it passes through 1, 0. All you have to do is plug in 1 for x and 0 for y and see if it works. And if I do focus in on G, and I plug in my 1 for x and my 0 for y, 0 over here, so there's really a 0 for y, you will see that that's the only one